Okie dokie artichoke. One more section in Venema's Chapter 3, and Venema's Chapter 3 closes with a look at the three parallel postulates and a little bit about how neutral geometry connects with incidence geometry, which was the thing we had looked at back in Chapter 2. I'm going to do a little bit in this video with the parallel postulates. We'll spend our class time making the connections between the parallel postulates, not between the parallel postulates. We're going to spend our class time making a connection between neutral geometry and the incidence axioms that we looked at the beginning of our course. So by way of reminder, because there's no way you have forgotten these, three parallel postulates. They are mutually exclusive. One of them has to be true in any geometry you create, but not more than one. They are the trichotomy, the Euclidean parallel postulate. Given a point and a line, there is exactly one line through the point parallel to the line. In the hyperbolic version, there's more than one parallel line. In the elliptical, there is no line parallel to the given line through the given point. And all I want to say about these in this section is the following. The elliptical is not consistent with neutral, because we will prove very, very soon that neutral geometry allows for parallel lines. And as soon as your geometry allows for parallel lines, the elliptical parallel postulate is gone. So there are geometries where that works, but neutral is not one of them. Second thing second. We can create a model for Euclidean geometry, and that is exactly everything you studied in high school, and we use the Euclidean metric. The standard distance formula, square root of delta x squared plus delta y squared, everything you learned in high school geometry is going to be consistent. It's a good model. The coordinate geometry that you learned in high school is a good model for Euclidean geometry. Everything we are about to do that says Euclidean is going to be consistent with everything that you remember from high school. So a bulk of our course is going to be spent dealing with this thing and coming up with a model for hyperbolic geometry. The model for hyperbolic geometry is the Klein disk. And the Klein disk is the disk where x squared plus y squared is less than 1. It's everything inside of the unit circle. In the Klein disk, lines are lines the way we think of them Euclidean-wise. Those are lines. The trick will be measuring distance between points and measuring angles in this geometry. So we're going to have to come up with a metric that makes those distances possible, because remember, there's got to be a one-to-one correspondence between distances and all real numbers. So we have to be able to find 2 points that are as arbitrarily far apart as we choose while still containing those points in that unit circle. That gets tricky. We deal with that later. We'll also deal with how to measure angles, because we've got to get all possible angle measurements from 0 to 180 in the Klein disk. So that you know this model is coming. It is coming. I promise it's coming. We can't build it yet. That will be a significant part of our course. Okay, that's all I want to say about the three parallel postulates. That's it. That's section 3.7 in a nutshell. That's the whole shebang. Okay. When we get to class, we'll talk about neutral geometry, incidence geometry, how they are the same, how they are different. If they are different, you'll have to think about that. All right, see you then.